Okay. So, hi, this is Let's Discuss the Paper Soon After Reading It. In our journal club, we started to read one paper in 2 hours ago. And then from now on, we are going to start the discussion. First, let us introduce ourselves. Chan Shen, please.
Hello, everyone. My name is Qian Chen, and I'm currently a PhD student at Monash University.
Okay, thank you, Chen Shen. And me, Yota Kawashima. I'm a research assistant in Japan. And today, we are going to discuss a paper titled Temporal Irreversibility of Neurodynamics as a Signature of Consciousness by Laura de la Fuente et al., published in Cerebellum Cortex in 2022. Before the discussion, first I will give you just a quick summary of this paper. Okay, so this paper, as the title says, is talking about temporal irreversibility of consciousness. But the idea, the background of this study is that the brain receives sensory inputs from the external world and generate conscious experiences. And then this, conscious experiences is temporarily irreducible. What this means is that, it just flows from the past to the future. So you can't experience from the future to past that kind of, temporal asymmetry exists. So the prediction is that, this temporal asymmetry should be observed in brain activity when we record the data the participant, or in this case, the non-human primates in a wakeful state, because they should have some, conscious experiences, which is temporary asymmetric. On the other hand, if we observe the data or record the data while the subject participant, the monkeys, were in unconscious states, such as sleep or anesthesia, then that should not reflect or have the temporary asymmetry. So meaning that that kind of brain activity data should show temporal symmetry. And that is kind of the prediction or hypothesis. In order to test this question in this study, they used machine learning, deep learning techniques. So the idea is that, we first have a decoder that can classify real data versus the inverted data of the real data for each conditions, for wakeful states and sleep states and anesthetized states. And if the decoder can classify or distinguish the real data versus inverted, time series data, then it means that the data have temporal asymmetry, because if it's temporary symmetric, the decoder should not be able to distinguish the real data from the inverted time series data. Then they focused on frequency and power at a certain frequency and also phase, and input these data to the decoder and train the decoder. And the result was that if they input the data from wakeful states, then the decoder can classify the real data versus inverted time series data. However, if they input the sleep data or the trained decoder by using sleep and ketamine-induced anesthetized data, then the decoder could not classify the real data. And inverted time series data. And based on this result, they concluded that in the data from wakeful states has temporal asymmetry, meaning that it flows from the past to futures. On the other hand, the data from unconscious states like sleep and anesthesia, there are no such kind of temporal asymmetry. So it's temporary asymmetry. Yeah, that's just a quick summary of this paper. And Chanshin, do you want to add anything?
I don't have anything to add. I think your summary has captured the key information of this paper pretty much.
Okay, good. So shall we start the discussion then?
Yeah.
Yeah. So do you have any comments or question, or anything is fine? But
I actually have a few probably a bit more specific kind of point of discussion, but first of all, I'd like to thank the authors for writing such a clear and easy to understand paper. Despite their origin, like the method they use are actually very complex. I actually understand, I would say 60 or 70% of their deep learning methods, despite the fact that I actually work on psychophysics and don't really do any work on this kind of modeling. Yeah, I do have like 2 to 3 things to talk about, but do you have anything to talk about? Like any comments? Or...
Yeah, so in the summary, I skip or just didn't mention the detail, the result and other discussions of this paper. But it's interesting that in some cases, in some conditions, the decoder can classify the real versus inverted time series data in sleep and anesthetic states. And in the discussion, they say that maybe it reflects the fact, or we can, based on that result, maybe we can say that during that period, if the monkey had some kind of dream or some kind of experiences in sleep or anesthetic states, then it makes sense that we can still decode or perform the classification for unconscious states. That part, of course, that was just a discussion, but it was really interesting to me.
Yes. Actually, with that, I think in the intro they talk about one of the reasons why conscious experience and its neural responses can elicit some kind of temporal irreversibility is that our experience is essentially we experience the flow of time only from past to future. And a possible explanation for why the decoder actually works in sleep and anesthesia is that some sense of time was still preserved during those states. And with that, I actually have a further question. The authors, in the authors' results, they talk about how the decoding models perform substantially better for wakefulness over sleep and anesthesia together. But they didn't really find any difference, like a huge difference between sleep and anesthesia in terms of decoder performance. But some sense of time is preserved in sleep better than anesthesia, right? Because I personally haven't gone into anesthesia before, but after you wake up from sleep, you suddenly feel like, oh, a long period of time has passed. But some people would report that anesthesia feels like a blink of an eye, which would represent a weaker sense of time. So I was wondering whether, it is possible to see some kind of difference
I see.
in irreversibility. Yeah.
So, okay. So you're saying that, after sleep, when you wake up, you feel that the time passed,
Yeah.
longer than, the recover from anesthesia. And then what is your expectation regarding, this time temporal asymmetry or irreversibility?
Let's say you would observe a stronger asymmetry in sleep compared to anesthesia.
Yeah. Sleep.
But then I was also thinking it could be related to the fact that their data come from deep sleep rather than the whole like sleep process, including stage 1 and then 2, and then also the deep sleep stages. And possibly the kind of sense of time was stronger in the, the REM sleeps compared to deep sleeps. So I was thinking maybe if, yeah. And also if they were to analyze the data from the entire sleep, including all the different sleep stages, which has already been found to elicit very different neural patterns across time. Maybe they could also observe some asymmetry there. But if they only select the deep sleep stages, which is characterized by slow waves, then yeah, they don't see asymmetry.
So about the time perception, I remember one paper talking that, we can estimate the time perception based on the pattern, the difference in the neural patterns. So if the patterns, stay the same, so basically no change, then you will perceive shorter time. But if the brain patterns change quite a lot during the same period, then you feel longer time. That kind of paper. And in that sense, even though we see the fluctuation in the brain patterns or brain activity quite a lot, as long as it is temporary symmetric, then there should be no differences in time perceptions, I guess.
Right. Oh yeah, because sleep overnight is like first you enter like a light, how do I say this, closer to awake kind of level, stage 1, and then REM, and then you have deeper sleep, and then towards like the end of your sleep, you go back to like the stage 2 and then stage 1 and then awake. And then if you reverse it, it's going to be very similar.
Yeah.
Yeah, right.
Yeah, but it's a good point that we need to think about the temporal resolution or time scales. If we think about the specific time windows, let's say a transition from early stage of sleep to the next stage, then there is asymmetry, temporal symmetry. But if you're only focusing on the data within the same stage, sleep stage, then it's symmetric. So yeah, depends on what kind of time scale, time window we are focusing on is I think the key. I agree that if we are talking about the transition from one stage to another in sleep, then it's not symmetric, I think. So should be should be able to observe something. Yeah, I agree that.
Probably not directly related to whether, the animal or like the person is streaming or not.
Yeah. And yes, and do you have any other, questions, comments?
Yes, so this particular paper talks about distinguishing conscious states, conscious levels of consciousness, let's say, using temporal irreversibility. One of its comments in discussion makes me think about how this will work in terms of distinguishing conscious versus unconscious contents during wakefulness. Because in discussion on page 7, it talks about how temporal irreversibility of neural responses during wakefulness is consistent with the hierarchical manner of sensory information processing, where low-level sensory data coming from all different modalities get bind together and integrated into, an integrated perception of objects and dynamic scenes. So this describes this describes the process of how a consciously perceivable stimulus was processed and how it is possible to have temporal irreversibility. But what would happen if we were to present a stimulus under threshold, which means it's not consciously perceivable during wakefulness? Do you still have this kind of temporal irreversibility to some degree because this person is awake and you still have low-level processing? Or it is not, you don't really observe this kind of asymmetry.
I see. So, okay, yeah, that's a good point, I think. And then I think, yeah, to comment on that. And first, even though you present, under threshold, stimuli, yeah, we are sure that, participant will not see that stimuli, but participant still have some conscious experiences, not about that stimuli, but about other, maybe if you're talking about, let's say, some, masking technique, the participant,
like that.
Yeah, still see, the background, the display, for example. What you cannot see or what participant cannot see is only the specific target within the display, right? So, yeah. So in that sense, I guess, we should be able to see temporal asymmetry, irreversibility in the brain activity. And that is not because of that target that is masked by other, or that is invisible because of under threshold, but due to other, components or contents of experiences, such as, the display monitor and the background color within the stimuli or something like that. And that is one thing. And then the other thing, I forgot what I was trying to say. Yeah, I just forgot. Yeah. I just forgot. Sorry. Yeah.
Yeah, I was thinking, so this kind of reversibility is, I think somewhere it talks about the scale of this kind of reversibility, but does this in the context of brain activity, does it only applies to like the global states of the brain? or you can segregate the correlates of this particular sensory data corresponding to this particular stimulus, and whether that particular neural responses is reversible or not.
Yeah, I remember in the discussion, or maybe in the introduction, we can, we will have two different types of, brain activity. One is, the activity evoked by external stimuli, and the other is, internal, endogenous activity. And then it's possible that the endogenous activity is temporary symmetric because it's it's of course related to conscious experiences, but still not the content of conscious experiences. However, the brain activity evoked by external stimuli, that should reflect the content of conscious experiences to some extent, and then that part should be temporary asymmetric. Yeah, I now remember what I was trying to say regarding the previous Chanshin's question. That is, to be honest, the result of this paper is clear, but for me, there are some, a kind of ambiguous, statement in the discussion and also in the introduction, because in this paper, they try to link their idea with, thermodynamics, ideas. And then first, they are saying that, the external world is kind of temporary asymmetric or something. And then that should be reflected in the, or that kind of asymmetry can be, reflected in the conscious experiences, and then that conscious experiences generate brain activity. Therefore, the brain activity is temporary asymmetric, something like that. And I am not sure about that, discussion or that kind of logic. And maybe I might miss something important, but I can't understand, this thermodynamics, ideas on what does this relate to, conscious experiences, and also, so yeah, I just don't understand, why, only the external, the brain activity evoked by external stimuli should, reflect the temporal, should show the temporal asymmetry. Does it make sense?
Yes, I can't speak to you too much about the thermodynamics because I haven't studied physics since high school. um, but I guess I understand the last part of your confusion in terms of why internally generated signals are largely reversible, whereas externally stimulated brain signals, or let's say brain signals stimulated by external things, are temporary, irreversible. I think this could partly come from the ambiguity in the definition of what it means to have internally generated brain signals, because you can have an imagination, you can imagine seeing something, and that's an internally generated signal according to some other research. But I would say in this context, it's highly likely that your imagined experience would display some kind of asymmetry, right? So I think the kind of internal signal they're referring to is often correspond to those of the lower levels of consciousness. Although I don't know why they are necessarily internal. Or let's say it's like an absence of external stimulation. but then imagination. Well,
Yeah.
yeah, something like that, I guess.
Yeah. So, I mean, if you think about the dream,
Oh,
yeah,
yeah,
yeah, there are no external stimuli while in
exactly.
dream, so in sleep. So I don't know where that, temporary divisibility comes from. But yeah, anyway. Yeah, I think it's better to mention another thing that, it's even without any external stimuli, the author mentions that it's possible that some activities, maybe not brain activity, but some physiological activities like hemodynamic response to something show temporal asymmetry something. That was, I think, mentioned in the introduction discussion.
Mm.
So that is not because of the that asymmetry is caused not by the external stimuli, but by the nature of physical structure or I don't know, the mechanism of cells or something like that. So
Yeah, I understand your point. Hmm.
mm,
Yeah, they probably, I think another hidden assumption they have by relating conscious experience of time to, there's definitely some kind of temporal asymmetry in brain is the very fact that we must be able to find neural correlates of consciousness, and conscious experience and brain activities must mirror each other kind of understanding, I guess. In fact, in their intro, I think they are not strictly, how do I say this? They don't strictly tie themselves to this kind of idea because they actually pose three possibilities of how
yeah.
temporal asymmetry can be presented in the brain. The first is what you mentioned, that only conscious states can elicit irreversible brain responses. But then there are also two other possibilities where asymmetry is inherent in the brain activity across all states, and then between brain states you have these different things happening. Yeah. But their results kind of rejects um the other two possibility where asymmetry is inherent.
Yeah. Yeah, I didn't include that part in my summary because I want to make my summary shorter, and then
Yeah,
including that other expectation takes time. So
and also I didn't really fully understand the differences between the two possibility that assumes asymmetry is the default of the brain. Like how the two differ from each other, I don't fully understand. So I kind of just, it's fine to skip through those, I
yeah,
guess.
my understanding is that the first is just physiological process in the brain, so it's more to do some biology mechanisms. But the other expectation is that, or interpretation is that first of all we or develop in some environment, and then as we grow up the brain changes the connectivity, and then that connectivity is to survive in the external world. So some properties in the external world should be already captured the in the brain, something like that. So it's more to do with learning. So the brain learn that kind of asymmetry, or not learn maybe, but reflect the symmetry in the physical world as the brain developed. And then by default, that asymmetric patterns in the brain activity is observed, or something like that. Yeah.
So okay, so the two possibilities differ in the cause of why that happens.
Yeah.
And even if the results were to find, all states, anesthesia, sleep, and consciousness show asymmetry, they cannot really distinguish between the two possibilities here.
No.
And also their data use only animals. So I was thinking about, a developmental perspective where you can use newborn babies and then toddlers and then, adults, compare their brain activities or something like that.
Yeah. I also wonder whether it's possible to, do the same, analysis to EEG data, because, this paper used ECoG data, which is difficult to, get from human. But if you want to test, your ideas, toddler, kids and adult, then EEG is better or ECG is,
Yeah, yeah.
So yeah. Yeah, maybe another interesting point is that they use the public data, publicly available data. And yeah, that was interesting for me, because if we have some clear idea what we want to test, we don't need to record the brain activity by ourselves, and we can use the data already available.
I thought that's what our lab has been doing.
Yeah. That's
most of the time.
Yeah. Yeah, but I don't know whether whether the authors or I don't think the data collecting team is in this author list. I mean, in our lab, we ask collaborators whether we can use their data to analyze and then have some result. But this is I think uploaded. This data set is uploaded somewhere, and then just analyzed by themselves, something like that. So yeah, but anyway,
authors list.
Authors list. Wait, maybe what I said is wrong. I don't know about the data collecting team. Sorry. Maybe no, because the method part, I saw link to the website where the data used in this study was uploaded, and then that website was kind of organized or managed by another institute in Japan, one institute in Japan. But I did not see any authors affiliated in the Japanese institute. So I expect that there are no data correct, there are no researchers who collected this data in this paper or authors. But maybe I might be wrong. Yeah. Yeah, that was not related to this paper content, so maybe should stop talking about this. And yes, anyway, so we've already discussed for this paper for 30 minutes or something. Yeah, if you don't have anything to say, maybe we can wrap up our discussion here. But do you have anything?
No.
No? Okay, then
No.
let's finish here. Yeah, see you. Bye bye. Next week.